Kinematics is when you study physics, there are two things. One branch is you only study motion. That is called kinematics. If you only study the motion, that is called kinematics. And you do not study the cause of motion. If you study the motion as well as the cause of motion is like what is causing that motion, like forces and all, cause of motion. That branch is called dynamics. Kinematics, dynamics, and this whole thing is called mechanics. So physics may we are learning mechanics, and it will have two areas where right now we are focusing on only motion, not the cause of motion. As such, we will study motion. That is called kinematics. And now I'm moving on and trying to teach you what is kinematics. Now, everyone should know what is the difference between, in the previous lectures when I was doing vectors with you, what is the difference between distance and displacement? Can anyone tell me? Distance and displacement. I will make you understand that very quickly, properly again, and please pay attention. If a body moved from A to B 100 meters along this path towards east, then the body moved from B to C towards south. Again, it was 50 meters, suppose. And now it moved towards west. Again, 100 meters. This angle will be 90, this angle will be 90. Now, this is 100 meters. Again, we reach this point called D. If I say this point is A, B, C, D. Now, can you tell me what is the total distance covered by the body from A to point D? Distance covered.
50 meters.
250 meters. 50 meters is the answer.
250 meters.
50 meters in the direction
250
of AD.
meters.
Sir,
Towards
displacement is
50.
50 meters. 50
meters.
meters. 250 meters.
250 meters.
50 meters.
Now, okay. Displacement is 50 meters, but that is not the correct answer. All of you need to learn this. Displacement is a vector, and displacement's definition, I told you. What is displacement? The vector, please note it down. The vector joining the initial position to the final position. Initial position to the final position. That is called displacement. So the displacement, the initial position of the body is here, the final is here. The vector joining the initial position to the final position is this vector, and the magnitude is definitely 50 meters. So the answer will be 50 AD unit vector. This is the displacement, and displacement is a vector. You need to specify its magnitude, 50 meters unit also, and you need to specify its direction also. We can do that, but right now I want you to write it in terms of AD cap. This is the proper way of answering this question. Whereas distance, you can say D is equal to 250 meters. It has no direction. So please note it down. It is just a scalar. The actual path covered by a body is called distance moved by a body. Now, if you have understood the difference between distance and displacement, it will be easy for you to answer my next question. And my next question is, there is a body which is moving in a circular motion. This body starts from this point. It started from this point A. It goes in the circle in this direction and it reached B. The radius of this circle is 10 meters. Can you tell me when the body reached from A to B, what is the displacement and what is the distance? Quick.
What's the center point?
Center is here, O. I am saying the body moved like this along this circular path and it moved from A to B along this circular path, reached here like this. Now, you have to tell me what is the distance covered and what is the displacement. Quick.
It's like the distance is 41.42.
Correct. Okay. So,
We can.
now, everyone please pay attention and learn. For a circle, what is the total circumference of a circle? Is it 2 pi r? 2 pi r is the circumference of the full circle. So what will this half circumference be equal to? Pi r. 2 pi r by 2. 2 pi r divided by 2, which will be pi r. So the distance covered will be the length of this semicircle, and that will be pi into r, which is 10. This much meters. That is your answer. Distance. You can keep the value of pi. Pi is 3.14. Now, the displacement will be a vector. No. The body moved along this path. Please pay attention. No. It traveled like this along the circular path, reached here, and the distance covered is half of the circumference of the circle. Circumference was 2 pi r. I divide 2 pi r by 2, semicircle. And this path covered is pi into 10. This is the answer, distance covered. Displacement will be a vector. So I will draw an arrow. And this vector will have displacement will be the line joining, the vector joining the initial position to the final position. This is my initial position. This is my final position. You have to join the initial position to the final position, and this vector IF represents the displacement, and that is equal to 20 meters, and direction is from either you write AB cap. AB cap means a unit vector from A to B. This is how you write displacement. Learn to write the two things correct. It will help you a long way in your kinematics. We will be doing more and more interesting and intricate problems. Right now, I just gave you a proper introduction to what is displacement and what is distance and what is the difference between the two. Now, if I ask you an interesting question, now you can unmute them. All of you, please pay attention. Can I say distance for any motion of a body? Distance will always be either greater or equal to displacement.
Yes.
Yes, sir. Yes,
Yes,
sir.
Greater.
Yes, sir. It will be greater than or
Greater
equal
than
to.
or equal to.
Can be
Greater than or
equal.
equal to.
Also.
Distance will always be
it depends. It
Greater
depends.
than equal to displacement.
Displacement. Yes, sir.
magnitude. Distance will always be greater or equal to the magnitude of displacement, always. Maximum thing that can happen is it can be equal. Displacement will always be less or equal to. Now, which is the case when distance and displacement will be same?
When it is in a straight line.
And the
When
motion
it's
is in
same
straight line.
direction. When the
Straight line.
motion is in same
Motion
direction,
is in
sir.
straight line.
If a body moves in a straight line forever, if the motion is happening only in one direction, same direction, one direction, then distance will be equal to displacement. Otherwise, distance will always be greater or greater than displacement. Equal सिर्फ तब होगा जब good observation. We understood this. We understood both distance and displacement. And I want you people to now learn what is velocity and speed. What is the difference between speed and velocity? And it will be so easy for you to understand now because you have understood the difference between distance and displacement. Speed is defined as distance covered upon time taken. Distance covered upon time taken. And velocity is defined as
Displacement upon time.
displacement upon time taken. I am writing it in short form. S is displacement vector upon time taken. So will velocity be a vector?
Yes.
Yes.
Yes, sir.
Yes.
Correct. Will speed be a vector?
Scalar. No, sir, it's a scalar.
Scalar.
It is a scalar quantity.
It has no direction. It's a
Scalar.
This is a vector. It has direction and magnitude both. This is a vector. And you know very clearly what is the difference between speed and velocity. Beautiful. Your concepts are getting shaped. And the moment I ask you a question, everyone has to give an answer with full clarity. No confusion. I have made everything clear. Distance and displacement are two different things. I told you distance is actual path covered. I told you displacement is the vector joining the initial position to the final position. Remember these two. Similarly, I'm telling you speed is distance covered upon time taken, velocity is displacement upon time taken. And now, when I have told you this, I expect you to do the next question correct. And let me see how many of you will be
Sir, I
correct.
have one doubt.
Quick.
Sir, does Google Maps measure the velocity or the speed of the body?
Beautiful question. If you are driving your car, the speedometer shows you speed or velocity?
Speed, sir.
Speed.
Speed.
So instant.
There is one more thing there. Is it
Instantaneous
showing
speed.
you? It shows you instantaneous speed. Speed at that instant, particular instant. There is another thing called average speed. We'll be coming to that. But now, the question was in Google Maps. When they show you, what do they show you? Just make me understand that. So I use Google Maps. There is an arrow, and the arrow doesn't. Is it mentioning your speed?
Yes, sir, it mentions. Yes.
Yes, sir.
Okay.
On
If
the
it is
bottom.
speed, that is your speed at that instant. ठीक है?
It's mentioning your direction also.
Direction also.
It also
it-
mentions the direction.
So it is telling you your velocity rather.
So
It
it
is not-
doesn't mention. So it doesn't mention your direction.
Yeah, they mention your
Mentions.
direction also.
The arrow.
Mention direction.
One is telling you your the magnitude and direction both. It is your velocity at that instant. Instantaneous velocity. At the moment, please understand this basic definition of speed and velocity. And now I'll come to all your questions and all these intricacies that are coming to your mind. I will remove them right from the roots. Don't worry. So let's just be patient for a few minutes and understand this. So speed definition is this. Velocity definition is this. Let's understand this. Average velocity, instantaneous velocity. Let's understand the difference between these two. We understood difference between distance covered by a body and displacement of a body. We understood the difference between them in the last class, displacement. We understood this difference. Based on this, we know Speed is defined as distance of upon time taken. Distance covered upon time taken. Speed is defined as this. It has no direction. It cannot be negative. Displacement. On the other hand, velocity is defined as displacement vector upon time taken. And I told you how do we define displacement vector? The vector joining the initial position to the final position. Vector joining I to F. I is the initial position, F is the final position. This is the summary of the last lecture, which we did. We understood the difference between distance and displacement. We understood the difference between speed and velocity. Velocity is a vector, speed is a scalar. It has no direction. It's a number, cannot be negative. Velocity is a vector, it has direction, and it can be positive or negative both. Negative sign will mean opposite direction. That's it. We'll come to this part. Now, let's understand what is average velocity, average instantaneous velocity, what is average speed and instantaneous speed. Let's get that clear, everyone. Average speed before we come to velocity and instantaneous speed. Instantaneous speed, sorry. Let's understand the difference. When I'm driving a bike, the speedometer gives some reading. When you are driving a car, the speedometer gives some reading. That reading, when the needle is at 100 or 200, because I don't ride the bike lesser than 200 speed, bragging. Now, the speedometer, the needle is pointing at a certain speed at that time. And you say, oh, 100 की speed से गाड़ी चल रही है. Praveen sir, आप 200 की speed से गाड़ी क्यों चला रहे हो? This is not safe if the needle will be at 200. So आप इस तरह का जो statement देते हैं और वो जो needle is pointing at some value, that is the speed of the car at that instant. That is called instantaneous speed. We will understand what is the difference between this and what is the difference between these two, average speed and instantaneous speed. All of you please be attentive and let's see if you can understand it with full clarity. I'll be very happy. Let's see this. Now, I'm going to drive a bike from here. This is my bike. This is like a sports bike. Okay, something like this. I'm seated. I have a helmet and I am holding the bike. This is me driving a bike. You can see the bike is very stylish. Now, I started driving the bike from here and I drove the bike in this direction towards east. Suppose this is east. I kept on driving the bike towards east with my speedometer. First, I covered a distance of 1 kilometer. That means 1,000 meters, 1 kilometer in 5 seconds. Then here I stopped my bike. I stopped my bike for some time. I stopped here and I spoke to my friend. I put the brakes, slowly slowed down, but I took 1 kilometer, 5 seconds was the time I took. And then I spoke to a friend who was standing here. Then I again started accelerating and then I again covered the remaining 2 kilometers. This is 2 kilometers. in next 5 seconds. I drove very fast now.
Hello, sir.
And I reached from A to B to C.
Hello.
And when I was at B, I spent 5 seconds to talk to my friend. I was standing here, spending time, talking to my friend, 5 seconds. Now, yes, you have to tell me what is my average velocity from A to C. Let me see who can answer this. Average speed from A to C. What is my average speed from A to C? What is average speed defined as? Total distance covered by the body upon total time taken by the body. Total time taken by the body. Now, based on this definition, let me see how many of you can tell me from A to C, what is my average speed?
0.2 kilometer per
0.2 kilometer per second.
Kilometer per second.
Meters 0.2 kilometer per second.
Meter per second.
0.2 kilometer per second.
3.2 kilometer per second.
300.
300.
Now, so I just realized when 20 of you will speak at the same time, mute all. When 20 of you will speak at the same time, it will be a total wastage of time for everyone. Please type your answer in the chat box. Whatever is your answer, I want to read your answers. So please type your answers. Okay, 200. You got 200? Let's see. Okay. Many of you, let's see. We'll have a discussion later. So 300 meter per second, 200 meter per second, these are the answers that are being given. Okay.
300 meters.
हाँ, let's see. 200 and 300 के बीच में many of you are fluctuating. Many of you are giving 200. One few of you are giving 300. And let me see. Let's try to do this question. Everyone, please pay attention and be fully focused. These concepts are going to help you big time in your competitive exam preparation in future. This is important for IIT also, NEET also, any exam and your school as well. And it is an intellectually, abhi to shuruaat hai. We'll go very deep and I want you people to enjoy the journey, and you will enjoy the journey only when you will be attentive. Now let's see. Everyone, please be attentive. From A to B, let's see how much distance we have covered. What is the distance covered? 1 kilometer plus 2 kilometer. Total distance covered is 3 kilometer or 3000 meters. That is the total distance covered. Total time taken is, I took 5 seconds from here to here while I was driving. I spent 5 seconds here when I was talking to my friend. I spent 5 seconds in the further journey. So total time that I took is 15 seconds to reach from A to C. 15 seconds. So time taken is 15 seconds, and hence the answer is 200 meter per second. So many of you were giving me this answer. I am happy with that. Those who were giving me 300 answer, what they were doing is they were not ready to accept that this 5 seconds which I wasted in talking to my friend, should we count it or not? I can understand that. They were confused about this point. Should we count it or not as a part of his journey? Yes, we have to count it. Please understand this. Any amount of time, whatever you did in between, you have to take the total time from here to reach here. Whatever is the total time taken, you will consider that total distance, 3 kilometer, and you got the answer. It was easy. How many of you understood it? Give me a thumbs up. Just give me a thumbs up so that I'm sure we are on the same page, because I am going to make things difficult for you today. I am going to give you very challenging questions very soon. I just want to be sure that the concepts are getting cleared. So give me a thumbs up if you have understood this question. It was quite easy, and I can see majority of you are giving me thumbs up. Okay. Okay, good. Shambhavi is saying yes. So now almost every child has realized that this is the correct answer. Okay. Now, let's see. I am going to intellectually challenge you very soon. Next question. Alert. Again, now this time I will make myself like this. I'm not going to be too creative with my drawing skills. So I am going to drive my car or a bike from point A, and I am going to drive it with constant speed. And my constant speed is going to be 20 meters per second. I'm going to drive it with constant speed 20 meters per second for 1 kilometer distance from A to B. Till B point, I was driving myself with 20 meters per second. After reaching B, I realized I am getting late for my meeting. From here onwards, I started driving fast and my speed was uniform again, constant again, and it was 40 meters per second. I increased it so that, and it was constant throughout it. How it was constant, how magically you can be immediately at 40. You should have pressed the accelerator. You should have taken some time to reach from 20 to 40. You should have taken some time. Yes, I agree. But right now we are assuming that at B, magically, I got my speed uniform and that is 40. So there is some high-tech AI-driven car in which I'm sitting. I have to just put the value and I'll get that constant speed. So I am moving with a constant speed for next 4 kilometers. And I reach point C. This time you have to tell me what is my average speed from A to C. We will keep increasing the level of difficulty if you keep answering correct. So please be attentive and answer. Average speed from A to C. Average speed from A to C. Always go back to the basics. What is the basic? Total distance covered upon total time taken. That is going to be your answer. And I am seeing some answers on my chat. Yes, 30 meters per second, 3.33, 33.34, 33.33, 35. These are the answers being given, maybe calculation. Okay. I can also see 11.11. Array. Let's see a very different answer. 48, 33. So there are a lot of variety of answers. That means a lot of people are doing it wrong. Some of you are getting it right. Let's see, let's see. I want to see your brains. I want to see who all are going to do it right. There is something you have to think. And slowly, I will make it more and more exciting and interesting if you keep responding. Let's see, let's see. Let's keep learn also. Let's keep learning also at the same time. So from A to B, I know the distance covered. From B to C, I know the distance covered. From A to C, total, I know the total distance covered is 5 kilometers. So distance covered by the body is 5 kilometers or 5,000 meters. This every one of us knows. Okay, half the job is done. What is the total time taken? How do I find this time? So let me assume the time taken from A to B is T1. I don't know the value. And from B to C is T2. If I can find these two times, then total time taken will be T1 plus T2, and I will divide this by T1 plus T2. I will get my average speed. Total distance covered upon total time taken. Am I right? Now let's find out T1 and T2. For this distance, 1 kilometer, the car or the bike was moving with 20 meters per second. So can you tell me what is the time taken? Time taken is distance, time taken T1 will be equal to distance covered, which is 1000 meters, divided by speed during this motion. Speed is 20 meters per second. So you can see the time T1 from A to B is 50 seconds. I want to now find time taken from B to C. From B to C, the car moved 4 kilometers. That means 4,000. This is the distance covered, 4,000 meters. And what was the speed during this time? 40. 4,000 divided by 40 meter per second. That was the speed. So I'll get T2. This time will be 100 seconds. Now, the total time I took from A to C is T2 plus T1. And that will be 150 seconds. So my answer should be 5,000 divided by 150 seconds. That should be 33 point meters per second. Very good. Lovely. All those who answered 33.33, give me a thumbs up. I want to see how many people were right. Give me a thumbs up. I want to see how many people were right in answering this. Okay. Quite a few. Quite a few. Now, how many of you have understood it now? I will give the next question tougher only if I feel majority of you have understood. So please give me a thumbs up if you have understood it. Give me a thumbs up if you have understood it now. Okay. Okay. Great. Great. Now, next question. Let's see. Next question. So you are understanding that average speed is being calculated by finding the total distance and total time taken. What is going to be average velocity? What is the definition of average velocity? Total displacement upon total time taken. Lovely. Now, I'm going to give you a good question now. Everyone has to be on toes. And let me see how many of you can be very fast to answer this. I am moving from here, point A. This is point A. And I'm going to move 5 kilometers with a speed of 100 meters per second. I have a constant speed here. Speed is this 100 meters per second for 5 kilometers. Then I moved another 5 kilometers with a speed of, my speed changed. Speed was 200 meters per second. Third, there is a third motion. Now I will return back on this back drive. I will come back and reach point A, B, C, and back to B. I came back to B after going there. Here I stopped for 10 seconds. I was standing here for 10 seconds. Then I moved back with a speed of 100 meters per second while returning. So now there are three motions. First motion is A to B. Then I moved from B to C with this speed. B to C. This is A to B. And then I return back from C to B in this direction. And this is 100 meters. Now, you have to tell me what is from A to B to C to B. This is the path. This is the path. So my initial position is at A and my final position is this is where I've reached. And I followed this path. You have to tell me from A to B, what is my average speed? Average speed. And second part is my average velocity. And I will be really impressed if you do it right, both of them. Both of them right. I waited here. I wasted 10 seconds here. Just remember this also. Don't ignore this. Now try to do it. I will be royally impressed if someone's answer is right. Speed and velocity both. Average speed and average velocity. Both. Let's see. Nice. I can see Yatharth, Sparsh, lot of answers I'm getting. Nisha, Jash, Samyak, Akshaj, Divyanshi, Taha, Namamrita, Pradhan. Let's see. Amrut, Sairam. Please tell me answers in SI units. That's the norm. SI units means meters per second or seconds. So always whenever they give you values in kilometers and all, convert it. Akshaj, Yatharth. Okay, let's see. Average speed. Let me see who all are champs now. Ready? Let's see. We'll make things more and more interesting. Let's see. From A to B, distance covered is 5 kilometers. This everyone knows. I don't need to worry about it. I'm solving the question. I will see who all were right. 5 kilometers is the distance covered. Okay, this I know. From A to B, what is the time taken? My speed was 100. So time taken would have been T1 would have been, if I say this time is T1 while going from A to B, T1 would be 5,000 meters divided by speed, which is 100. Time is distance upon speed. We know this formula. Speed is equal to distance upon time. So, for this region, A to B, time will be distance upon speed. Distance covered, 5,000. Speed is 100. So, time taken is 50 seconds. So, T1 comes out to be 50 seconds. Okay, this I know. From B to C, this motion, quickly, everyone attentive, 5 kilometers with a speed of 200 meters. So T2, if T2 is the time for this motion, it will be, T2 will be equal to 5,000 meters divided by 200 meter per second, which will be in seconds. Now, this will be 25 seconds. Okay. T2 is 25 seconds. There is this time wastage. Let me call it T3, which I wasted here. I was standing here for 10 seconds. Now, the fourth is I return back and I return back with this speed from C to B. And let me call that as T4. T4 will be equal to distance covered as 5,000 meters upon speed is 100 meter per second. So time T4 will be 50 seconds. Now, I am almost done. So my average velocity, average speed, average speed will be equal to total distance covered. 5 kilometer while going and 5 kilometer while coming back. Total distance covered is 15 kilometer. That means 15,000 meters divided by total time taken. Total time taken is T1 plus T2 plus T3 plus T4. All the 4 times. So this is 50 seconds. This is 25, 75. 75 plus 10 is 85. 85 plus 50 is 135 meters, seconds, sorry, 135 seconds. Now, so my average speed comes out to be 3,000 divided by 27. So 1000 by 9, which comes out to be whatever meter per second. Yes, I can see this answer I was seeing. So average speed, lot of you were right, and that is the answer. Yes, correct. Lot of you were right here. Good. Let me see average velocity कितने बच्चों की correct थी, and I have the chat. I will compare it and I will see how many of you were right. So average velocity के लिए the total displacement, time taken will be same, but total displacement will be, so I'm going to write it here. In such a small place, we'll be able to get the answer. Average velocity vector is total displacement. Can anyone tell me what is total displacement? Total displacement is this vector joining the initial position to the final position. He reached here. This vector represents the net displacement. This is the net displacement. The vector joining the initial position to the final position. This is the final position, this is the initial position, and this is 5 kilometers. So average velocity, total displacement is 5 kilometers, which is 5,000 meters divided by, and it is directed from A to B. So I will say AB cap. We'll come to this unit vector along AB. Divided by time taken, total time taken will remain the same as here, 135 seconds divided by 135. And now I want to calculate it. 1000 upon 27, 1000 upon 27 meters per second, and it is directed from A to B, or AB cap. This is how we'll write it. Too much hodgepodge. Now, this is roughly
37, I guess.
37 point something. Now, I want to know how many of you were right. Give me a thumbs up. Yes, I can see Namamrita Pradhan, Vaibhavi, Nikunj. Yes, they are right. ऊपर जाइए chat पे. I want to see more. Those of you who did it right, please give me a thumbs up. Okay, quite a few. Very good, impressive. So I have champs with me. Great. Khushi Sharma, Malar Patel, nice. So lot of easy. Okay, good. You want challenging questions. Ready? It was important to be systematic, easy, and make you understand these things. And we'll come to this. Ready? So we understood instantaneous speed. Instantaneous is very easy. Like the speedometer will give you instantaneous speed. Acha, can anyone tell me instantaneous speed and instantaneous velocity? Will their magnitudes will be always equal? Magnitudes. Yes or no? Those who say yes, give me a thumbs up. Instantaneous speed, please understand what I'm saying. Instantaneous speed will always be equal to instantaneous velocity magnitude. Is it true or false? Those who say it is true, give me a thumbs up. If it is true, give me a thumbs up. Instantaneous velocity and instantaneous speed will always have same magnitude. The only difference will be, yes, this is true. The only difference will be that this will have a direction and this will not have a direction. That's the only difference. Otherwise, their magnitudes will always be same. Now, at a particular instant, speed at a particular moment at that instant is called instantaneous speed. Velocity at that particular instant is called instantaneous velocity. You can write the definition. And average velocity and average speed we found by total distance covered upon time taken is average speed, and total displacement upon time taken is average velocity. Good. All of you understood this concept. Now, moving ahead. Average velocity, average speed, very good. And I see a lot. This is going to be a really beautiful concept, and you will be definitely mesmerized if you understand this. Children, please pay attention to this. Very intricate, very beautiful concept. This is called relative velocity. In fact, motion is always relative. Can you tell me if I am standing in this room, what is my velocity? What is my velocity? No, it is not zero.
The speed and the delay is to one.
So, children, please pay attention. If you are observing me, or a person sitting in this room is observing me, there is one child who has accidentally come to the class today. If anyone who's in this room or anyone who's on the surface of the earth is observing me, for him, he will feel that I'm at rest. The way you are feeling. The way now, if there is an alien who's watching the earth from space, and the earth is rotating about its axis and it is revolving around the sun, for him, I am in motion. So the same person is in motion relative to that alien, and for you, I am at rest. So now you have to understand a very important part of physics, which is motion is always relative. It is always relative to a frame. You have to define the observer. It cannot, there is nothing like absolute motion. You can't say whether I am at rest or I am moving. You can't say that ever. Unless you specify at rest to whom? Who's the observer? So you can define my motion relative to someone. You can define my motion with respect to someone. You can define my motion with respect to some observer. Okay, as observed by that person, you are at rest. As observed by that alien, you are moving. As observed by, so you have to specify the observer. So motion can never be absolute. Motion is always relative, and from here begins your journey of one of the most beautiful topics of kinematics, and that is called relative velocity. And I will make you fall in love with this topic in next few questions. Just pay attention. Attentive. So this whole concept is about understanding this one simple thing, that velocity of A as observed by B is equal to velocity of A minus velocity of B. Please note it down. Everyone, this equation, how do we read it? Please note it down. Velocity, this is read as velocity of A as observed by B. This thing. A comma B means velocity, subscript A comma B means velocity of A as observed by B, or sometimes we also say velocity of A with respect to B. Can anyone tell me who is the observer? A or B? B is the observer. With respect to B or as observed by B, you can see B is the observer. Who is he observing? He is observing A. So A is being observed and B is the observer. And that's why this term comes second. Observer is here. Understand this line, this equation, this one equation is this full chapter. And every question you will be able to solve using this equation. So we have to understand every term of this equation very properly. And We will solve very beautiful problems, very beautiful real life problems using this. So please be attentive. Now, velocity of A as observed by B is written as VAB, this symbol. And this means velocity of A as observed by B or with respect to B. Okay. This is equal to velocity of A minus velocity of B. Now, what is this velocity of A relative to? If nothing is written, because we just now understood, okay, we will never talk about velocity in isolation without specifying who is the observer. So never ever, when he doesn't say anything, he means relative to the earth. But you in your head from this moment onwards will never be confused or vague about it. You should always know velocity of A. When he is not writing anything, what does he mean? Velocity of A relative to the ground or earth. Velocity of B relative to the ground. Suppose there is one more thing I want to add to this definition. This equation, I want to tell you another form of this equation. And what is that form? Please pay attention. Velocity of A as observed by B can also be written as velocity of A with respect to x minus velocity of B with respect to x. What is x now? What are you saying? What is this x? You said relative to earth, we accepted. Okay, when he'll be silent, we'll assume it is relative to earth. What is this x now? X is any frame. Any frame. So, if I tell you velocity of A in a train with respect to the train is this. Velocity of B with respect to the same train is this. So, you are talking about the reference frame to be not the ground, but you are talking relative to the train. So X can be that train. X can be another planet. X can be some other frame. So we will come to that in general form. Just write down these two equations. X can be any frame. Just note down. X can be any frame or observer. And when nothing is said, we assume that the observer is on the ground, if nothing is said. Okay. Now, if you have understood these two equations, this chapter begins. This chapter starts, the beauty starts from the very first question. Let's see. I am going to ask you a very simple question to begin with so that you people don't start crying. And what is that question? The question is, a man is moving towards east with 100 meters per second velocity. Towards east. This man is called A. And I am going to name this A as Adi More. Okay. Adi More. I can see him on the screen. And there is another man who's moving. There is another man who's moving in opposite direction. This is a person M. Okay. Now, Minasri is moving in this direction with 100 meter per second. Now, when I say velocity of A is 100 meter per second, what do I mean? This velocity is with respect to who is the observer? Which frame? This is with respect to velocity. What will be the velocity? Question is, what will be the velocity of A as observed by Minasri? What will be the velocity of Minasri as observed by A? You have to tell me these answers. This is what, this is what. And first I want to make you mistakes, trying yourself. Then I'll teach you the right method to do it. And then we'll keep increasing. Every question will keep mesmerizing you. Let's see. Can anyone type the answer? Quick. Velocity of A as observed by Minasri. Velocity of Minasri as observed by A. You have to tell me velocities are vectors. Vectors are having direction. Direction is very important. So when you write 200 or 0, you have to tell me the direction. Those who are writing 0, 0 is the wrong answer. 0 is not the answer. So they need to be very attentive. Those who have given the answer to be 0. Those who are giving answer to be 200, they have to be very, very clear about the direction. And I will show you how to do it. अरे असली मजा तो नेक्स्ट क्वेश्चंस में आएगा, अभी इसे तो सीख लो. ठीक है. नाइस नाइस. ओके, इस क्वेश्चन को लेट्स यूज इट फॉर लर्निंग एंड द फन बिगिंस. ओके, एवरीवन अटेंटिव. Let me explain to you, let me make you learn this. Everyone stays attentive. And can I write velocity of A? Velocity, that one equation will always be used. That's it. Velocity of A with respect to ground, if nothing is set, is equal to, in vector form, if I assume this direction to be positive direction of x-axis, so can I write this will be 100 meters per second I cap. ये समझ में आ रहा है सबको? मैंने वेक्टर फॉर्म में लिख लिया. वेलोसिटी ऑफ ए as relative to the ground, velocity of Adi relative to the ground as observed from the ground is 100 meter per second. That is given to us. हमने इसमें कुछ किया ही नहीं. We just noted it down in the form of x-axis I cap, a unit vector, direction, because I need to be very careful about direction when we are dealing with vectors, and velocity is a vector. So whenever you are writing velocity, always be careful about the vector. Now, can anyone tell me what is velocity of Minasri as observed from the ground? Is it 100 meter per second I cap, or is it minus 100 meter per second I cap? This is. Now, if I want to find this, the process is very simple. It has already been told to you. This will be equal to VA minus VM. Simple. And when nothing is written, that means relative to ground, relative to ground. Yes. And these two we already know. So let me write down the value. This will be equal to the first one I'm doing. I am removing this. The first one. Now, attentive. Velocity of A relative to ground is 100 I cap meter per second. I am going to write separately, minus velocity of M in proper vector form is minus 100 I cap. So meter per second, this whole thing, meter per second. Now, the answer to VAM, velocity of A, Adi as observed by Minasri, is 200 I cap meters per second. Okay, this is the answer. And if you will do the other question, other part, which is velocity of Minasri as observed by Adi, this will be VM minus VA. And this will give you an answer, minus 100 I cap, minus 100 I cap. This answer will be minus 200 I cap meter per second. Now, there is something which I want you people to realize. There is something which I want you people to realize here. And those who will realize it will be able to enjoy the future questions. So these are the two results. Please pay attention. This is the first result. And this is the second result. And now, if all of you will give me your full attention, you will enjoy the future learning. Otherwise, you won't. Now, just see this. When I say I am going to find velocity of Adi as observed by Minasri, VAM, who is the observer here? Who will tell me? Minasri is the observer. Now, If I ask you one advanced question, and that advanced question is, what is the velocity of Minasri as observed by Minasri? Who will tell me? Everyone's attention has to be on the board. There is something very beautiful I'm going to teach you. Those who will pay attention will enjoy this topic a lot. Yes, velocity of Minasri as observed by Minasri will be what? 0. Yes, this will be Vm minus Vm. Vm minus Vm, obviously, and this will be 0. When I say VAB is equal to VA minus VB, so VMM, velocity of Minasri as observed by Minasri, will be equal to Vm minus Vm, which will be 0. Now, what does this mean? What does this mean? Please pay attention. What does this mean? This and this. I want to make you understand what does these two things mean. Pay attention. If suppose instead of us, we observing the motion, when we observe the motion, we are seeing this boy is going this way, Minasri is going this way. So we can see both their motions and we are standing on the ground. We are the third party. But now just see what Minasri is feeling about the motion. What is she feeling? What is her own velocity as observed by herself? Can anyone tell me? What is Minasri's velocity as observed by herself? So if we are sitting inside the brain of Minasri, what are we feeling? We are feeling Minasri is at rest. Her velocity is 0. She will not feel कि I am moving at all. तो ये जो velocity है ये हमें दिख रही है. Minasri को अपनी velocity दिखेगी 0. She will feel I am standing here. I am not moving at all. Velocity of Minasri as observed by Minasri. Now, observer is Minasri. We are thinking from her brain. And what is she feeling A's velocity is? What is velocity of A as observed by Minasri? What is she finding it to be? 200 I cap. That means she's feeling A is moving in this direction with 200 meters per second. And this is exactly what she will feel about A. This is exactly what she will feel about herself. And we can study and look at the questions from her perspective. If we start understanding what is, and I will give you questions, but first I want you to just visualize this. Now tell me the other thing. If suppose we say this boy is observing, is the observer. In the second case, what I have done is, when I say this, velocity of Minasri as observed by A, who is the observer now? In the second case, Adi is the observer. If he is the observer, what will be velocity of Adi as observed by Adi? Please tell me, velocity of Adi as observed by Adi will be 0. He will feel, I am at rest. This is how he is going to feel. And what will be the velocity of Minasri as observed by Adi? We have calculated that here. It is minus 200 I cap. That means he will feel Minasri is moving in this direction with 200 meters per second in this direction. And he is not going to move at all. He will feel, I am at rest. I am not moving at all. Now, how many of you have understood these two perspectives? Give me a thumbs up. Give me a thumbs up. Those who have understood how to find relative velocity and how to look at the whole situation. This, whatever is written on the board, if it is clear to you, please raise your hands. Give me a thumbs up. Okay. Okay. I will do some more problems. I can see I have got more than 50% raising, giving me a thumbs up, but I need more. I want every child to understand. Okay. Let's see. Ready? We will again give it an attempt from scratch. Everyone pays attention. There is a man standing on the ground and velocity of the man is 0. Rain season has begun and raindrops are falling down and raindrops will keep falling down vertically. And I am telling you that raindrops, though they should be doing free fall under gravity, they should be doing, their acceleration should be G, acceleration due to gravity. But I have told you that there is too much humidity in the air, there is too much, the raindrops are like facing a lot of air friction, and the raindrops are very light. So those raindrops are moving with a constant velocity. I have given you, they are moving with a constant velocity and they are falling down with a constant velocity, vertically downwards with a constant velocity, say 10 meters per second. And it is constant for every raindrop. Now, how will the man find the velocity of raindrops? He will find the velocity of, and the velocity of man is zero. Velocity of man relative to ground is zero. Velocity of man is zero in the first case. And velocity of raindrops is 10 j cap minus 10 j cap. Can I write this? They are coming down with 10 meter per second. If I assume to be this to be the x-axis, this to be the y-axis, I can say velocity of raindrops is what? Velocity of raindrops is minus 10 meters per second j cap. And I told you that is constant. They are falling with constant velocity, speed. Velocity of man is zero. What will be the velocity of raindrops as observed by man? That will be velocity of raindrops minus velocity of man. And that will be VR only, because velocity of man was zero, so VR. He will find that the raindrops are falling vertically. और यहाँ तक तो कुछ नहीं हुआ, यहाँ तक तो आप एंजॉय कर रहे हैं, रेन गिर रही है और मैन को लग रहा है कि रेनड्रॉप्स ऐसे गिर रहे हैं 10 मीटर पर सेकंड से. ये सबको समझ में आ रहा है? एवरीवन क्लियर अबाउट दिस पैराडाइम? नाउ the man starts moving with 10 meter per second horizontally in this direction. The man starts moving with 10 meters per second along horizontal direction. Now man's velocity is this in the second case. Now we are in the second case. You will tell me what will be the velocity of the raindrops as observed by the man. Let me see who will do it. What will be the velocity of the raindrops as observed by the man? Try to do it. Velocity of the raindrops. Man is moving with 10 meters per second. Yes. Raindrops are falling with 10 meters per second vertically downward. Man is moving with 10 meters per second horizontally. You have to tell me what will be the velocity of the raindrops as observed by the man. It's going to be tough. It's going to be interesting. It's going to be really, really interesting if you pay attention and try to understand it. You will see beauty in this. See this. If I find VRM, I told you this whole chapter relative velocity will be about this equation only. Velocity of raindrops as observed by the man will be equal to velocity of raindrops minus velocity of man. Simple. Just put it in the form of I cap j cap. Velocity of raindrops will be what?
10 j cap.
Minus 10 j cap. Not 10 j cap. Minus 10. Because vertical direction is positive. Raindrops are falling downwards. So I wrote minus 10 j cap. Minus 10 I cap. Velocity of man is 10 I cap. Now, this is velocity of raindrops as observed by the man. Can anyone tell me one more thing at the same time? What is the velocity of man as observed by man? Quick. He will feel he's at rest. Now let's see how the man is feeling about the whole situation. Everyone pays attention. This is a part of your learning. If you have not solved it yourself, it's okay. But learn now. Just see this, the beauty of these two equations and what is written here. Velocity of man as observed by the man. Let's see this. This is the man. Velocity of man as observed by the man came out to be how much? 0. If man is observing himself, he feels I am at rest, I am not moving at all. Even though we know he is moving. But how does he feel about it? If he is the observer, how does he feel about it? Velocity of man as observed by man is what? 0. He feels I am at rest. He is not going to move. He will feel that way. I am stationary. What does he feel about the raindrops? Velocity of raindrops as observed by the man. Please pay attention to this equation. What is written on the left side? Velocity of raindrops as observed by the man will be this. Let me see how he is feeling about the raindrops. Let me take one raindrop. This is that raindrop. He feels that this raindrop has a velocity minus 10 I cap. He feels raindrop has this velocity, which is 10, and has downward velocity, which is 10 J cap. Now, what is he actually feeling about the raindrops? They are moving the, what is the resultant velocity? The resultant velocity is like this, vector. That's why we spend so much time on vectors. So he feels that the raindrops are coming in this direction. This is the resultant direction of velocity. This velocity is this, as shown by the green arrow. And he feels raindrops are coming and falling like this. उसको हर एक raindrop ऐसे दिखेगा, ऐसे गिरता हुआ. Now, what will be this angle? This angle theta will be 10 upon 10, which is 10 theta is 45 degree, which is 1. 10 theta is 1, so theta is 45 degrees. So he will find the raindrops are falling along this direction. How many of you just understood this? Okay, raindrops will appear to be falling like this to this man, and he will feel he is at rest. So this is what is his perspective of the whole situation. So he feels raindrops are coming like this at an angle 45 degrees, and we will learn how to calculate this 45 degree and all. But right now, how many of you have understood that he will feel this kind of a situation, that raindrops are falling at an angle and he is at rest? How many of you understood this feeling today? Relative velocity wali. Okay, give me thumbs up. I want to see. Lovely. Now, great, beautiful. I'm sure this is too tough. This is a part of your 11th IIT preparation, relative velocity, and children there also are not clear. If you are able to understand, get the hang, it'll be